Hello and welcome back to another video. In this problem, we're asked how are the inverse sine, cosine, and tangent functions defined, and what are their domains and ranges. So these are all inverses, as you would expect, of sine, cosine, and tangent. So that means if sine inverse of x equals y, then sine of y equals x. If cosine inverse of x equals y, then cosine of y equals x. Finally, if tangent inverse of x equals y, then tangent of y equals x. These are all just the standard definitions of inverses. However, what you might know is that the domains and ranges are not what you would expect, because sine, cosine, and tangent are not one-to-one functions. For sine, for instance, I'll graph it right here. The sine function looks something like this. This is not passing the horizontal line test, because if, let's say, we draw a horizontal line like here, it's infinitely many times it's going to hit the function. So you have to restrict the function to a certain domain. For the sine function, that was chosen from negative pi over 2 to pi over 2. So these are the values on the sine function for which the inverse sine is derived. Therefore, if this is in the domain of sine, it's in the range of the inverse of sine. And the domain is the values which it hits, which is from negative 1 to 1. I'll draw cosine next. Cosine is, its inverse is taken from 0 to pi. So the range of this inverse function is 0 to pi, since the domain of the original function was, right? The domain of the original is the range of the inverse. The domain of the inverse is the range of the original, right? They just have to be swapped. So the domain of this function is the range of cosine over this range, which is negative 1 to 1. And finally, tangent inverse is the values of tangent from negative pi over 2 to pi over 2. And the values which it hits over this period, its own, this is the domain, The range, I'm confusing myself here. The domain on which the tangent is taken, right, because the tangent is not 1 to 1, is only one segment of this, so from negative pi over 2 to pi over 2, so therefore that becomes the range of inverse tangent. The domain of inverse tangent is the range of the function over this interval, which is from negative infinity to infinity. So hopefully that lets you understand how these functions are derived, not only with the standard definition of an inverse, where we're swapping the inputs and the outputs, but also with these special domains and ranges. Because the original functions aren't 1 to 1, we have to compress them.